So here one by one let us see. Let us take seismic method. In seismic method, what we are going to measure? We are going to measure just the travel time. We are going to make the measurement of travel time, right, of seismic waves. Though we measure just the travel time helps us to understand about the density of the subsurface, isn't it? Right? For example, if the rocks below the surface of the earth are very dense, sound waves will travel much more rapidly. Imagine beneath the surface of the earth we have a thick deposit of sand, then sound waves will not go as rapidly as in the case of rocks, isn't it? So, the measured property is the time of arrival of the shock waves, but the time of arrival help us to understand what is present below the surface of the earth. So, this is the surface of the earth. From here you are generating shock wave, the shock waves goes in and comes back, and here it is received. If the material is massive rock, the sound waves arrive in a shortest span of time. Suppose instead of rock, if you have sand, it takes some more time to reach this place. So, we make use of the arrival time to understand about the subsurface, right? Then let us have a look into gravity method. So, here is the method. In gravity method, what we are going to measure? We are going to measure just the strength of the gravitational field, maybe acceleration due to gravity we are going to measure. Acceleration due to gravity which we measure is also related to the density of rocks. Imagine beneath the place where you are in now, you have 200 meters thick of gold deposit, right? More or less a pure gold. You will experience more gravity over there because the specific gravity of gold is nearly 19, right? 19 gram per cc. So, over there, if you measure the acceleration due to gravity, the acceleration due to gravity we measure will be slightly higher than the place where there is no gold deposit, isn't it? As an example I am telling you. So, gravity measurement also depend on density. Already we have got two methods. See, that is why in geophysics we won't restrict our investigation only by deploying one method. Many times we may need to use different methods to come out with a meaningful interpretation. Already we have seen two methods in seismic methods as well as in gravity methods. In both, the measured parameter is different, but the parameter that is going to control the measured parameter is the density, right? The physical parameter or physical property of the subsurface that is going to control the measured parameter. Here is the travel time, here is the strength of the gravitational field. Both of them is related to density. Right? Then magnetic method. In magnetic method, we are going to measure the magnetic field. So, in gravity method, we were measuring the gravitational field. Here, we are going to measure the magnetic field. The magnetic field which we measure is going to be related to magnetic susceptibility of the formation. Suppose beneath the surface of the earth, if we have material that are very much susceptible to magnetism, that can be easily differentiated from the other regions by magnetic methods. Then the next is electrical methods. In electrical method, this is what we measure. The measured parameter depend on this. Then the next is induced polarization method. In induced polarization method, we measure the frequency of voltage that is also dependent on the electrical capacitance of the rocks. Right. Then self potential method. We are going to measure the naturally present self potential, the electrical potential that is also going to be related to electrical conductance. So, here we have couple of methods, right? Both resistivity as well as self potential method depend on the electrical conductivity of the formation. As I told you previously, that is why we don't use only one method, we use multiple methods to understand about the subsurface of the earth. Then electromagnetic method. So, electromagnetic method is also related to electrical as well as magnetic method. This also depend on electrical conductance. So, we have multiple methods to understand the variation in electrical conductance, how electrical conductance is helping us to differentiate different geological material present below the surface of the earth. Then we have radiometric, that works on the principle of radioactivity. This is mostly used to identify rocks that are very much radioactive, so that they may be storing large amount of radioactive minerals. Right? So, these are the method, what we measure, what it helps, right? How it is going to help. For example, we are measuring the earth's resistance. Earth's resistance is going to help us to understand about the earth's conductivity. If it is a good conductor, probably a formation which has got lot of water, or it may be a metal deposit, it will be a good conductor, isn't it? So, that is how we measure something, and the measured property help us to understand about the variation in the lithological formations or variation in the different geological formation below the surface of the region where we carried out the. Then we are also going to see briefly about ground penetrating radar, and the last chapter is going to deal with the geophysical logging method. That means whatever we have seen until now, it will be conducted in a borehole. This is the surface, this is the borehole. If you carry out the investigation in the borehole, then it is known as geophysical logging. So, here is a picture in which we are investigating the subsurface, right, looking for artifacts, archaeological material beneath the surface of the earth in a region in the central part of Tamil Nadu by ground penetrating radar methods. Right. Here we made a visit to a tunneling work for metro rail work in Chennai. The alignment was assessed by ground penetrating radar as well as seismic method, mainly to understand presence of cavities, right? What are all the likely rock types which we are going to encounter during the process of drilling, right? So, before the commencement of tunneling work, sorry, not drilling, tunneling work, these two investigations were carried out at this site. Now, let us have a look into very broad applications of the methods which we have touched upon, right? One is electrical. I have put some areas of application: depth to bedrock, elastic modulus, cavities and weak zones present below the surface, utilities, hydrological studies, something related to geotechnical, slope stability, something related to environmental engineering, waste disposal, archaeological investigation, geological investigations. Here I have put different methods which we are going to see during this course. First, let us take electrical method. So, electrical methods help us to understand about the depth to the bedrock. Electrical methods cannot be used to understand the elastic modulus. For example, what is the bulk density of the rocks? Difficult to answer using electrical methods. Cavities present below the surface, to some extent we can answer by electrical methods. Presence of utilities, buried pipelines, yes, right. Hydrological investigations, hydrogeological investigations, presence of groundwater, right. Groundwater can also be understood using the electrical methods. Slope stability, yes, for example, a slope in a mountain, whether you have a thick weathered formation, whether the slope is likely to be stable or not, we can deploy some electrical methods to understand about the nature of material covering the slope in a hill or in a mountain. In waste disposal site studies, electrical methods can be used. Archaeological, yes. Geological, yes. Similarly, I put a tick mark. Let us take gravity methods. Gravity methods, yes, at a broader level, including the thinning and thickening of the crust of the earth, right? Earth's crust thickness is nearly 35 kilometers. In some parts of the earth, it may be thinning. Beneath the oceans, it will be thinner, right? Due to the plate boundaries, what happens to the Earth's crust can be studied, right, synoptically over a large area by gravity methods. Gravity methods also is today used in hydrology, right, to understand about the change in water balance. Change in water balance affects the Earth's gravity, that can be picked up, right? So, like that, I have put the tick mark. Maybe as a last case, let us take up radar. That means in radar methods, we are going to send in the radar waves and detect the arrival. Radar methods also helps to understand about the depth to the basic basement rocks, understand about the cavities, presence of utilities. You would have seen, how many of you would have noticed today, right, along the roadways, highways, some people may drag a small equipment, something similar to a lawn mower, right? That is used mainly to understand where are the pipes, cables, because that particular company may need to cut the region there to lay their cables, right? So, before cutting the earth surface, they are investigating whether there are any utilities, right? For that, ground penetrating radar can be used. Also, to understand the subsurface conditions in hydrogeology, in groundwater, we can to some extent use ground penetrating radar, can be used to understand the nature of materials in the hill slopes, also in geological investigations. So, this page gives a synoptic view of different geophysical methods and what are all their application, in which area they can be put into use. Now, let us go in some more detail on different methods we are going to see during this course, right. First, let us take up electrical methods. In electrical method, there are different methods actually. First is electrical resistivity method. What are we going to do here? As I had mentioned you previously, we are going to measure the resistance or resistivity of the subsurface, right. How are we going to measure? By passing electrical current into the earth. So, here you can see we are investigating a site within IIT campus. We are applying current into the earth and measuring what is the impact of the applied current. Why do we do this? Mainly to understand what is the difference in the rock types horizontally. That means, when you move, if you consider this as the surface of the earth, along this direction, how the lithological condition changes below the surface of the earth. Here we may have sand, here we may have clay, right, here we may have silt. So, laterally, what is the variation? Or we can also use this method to understand the vertical discontinuities. This is the surface of the earth, right. Here you have soil, here you have weathered rock, here you have fractured rock. This can be also identified. That means, vertical as well as lateral variation in the earth's material can be brought out by electrical resistivity method. So, here we are investigating about presence of saline water in coastal part of Chennai. So, this is the resistivity meter which we use to carry out this investigation, right. Imagine, right, what happens to the earth's resistance if the temperature is increasing, right. When the temperature rises, the electrical resistivity also will rise, right. This is the temperature. As the temperature rises, resistivity will also increase, as you see in this diagram. Can we use this method to understand the rising magma? That means, whether the dormant volcano, is it getting activated? Can we check that? Yes, we can make use of electrical resistivity method, because the rise in temperature will result into rise in the resistivity, because when the rocks are beginning to melt, the resistivity is going to increase. Imagine there is a small volcanic crater as you see in this picture, right? Here the rocks are, this is a chamber magma. It is now getting reactivated. That means the temperature is going to rise. When it begins to melt, what will happen? You are measuring, let us say, Earth's resistivity at different places on the sides of these hills. You should continuously measure, right, with respect to time, which is really difficult, right? To understand the activity of volcanism, we need to deploy the instrument permanently. You are continuously measuring the Earth's resistivity. When you notice rise in the Earth's resistivity, what does it indicate? Probably here there is melting, increase in temperature leading to melting. Possibly it may erupt as a volcano. So this is one of the application of Earth's resistivity method. Here you see a image of the Earth's subsurface, right? This was taken at a site near Chennai, right? This is sea, right? On the other side is the land, right? The cross section helps us to understand the presence of water which is having low resistivity. When the water will have groundwater, that means this is ground, this is the earth surface. Beneath that you have groundwater. Groundwater with the low resistivity has been deciphered because of the effect of the seawater intrusion. Then beneath the surface you have very high resistivity zone. This zone is rock, right? Probably a rocky region below the surface of the earth. So we are able to understand about the nature of the material and also quality of groundwater using resistivity method. Then the next electrical method is induced polarization method. This is number 2, induced polarization method. So induced polarization method is based on energizing the ground with very high voltage. High amount of current is applied, right? What we are going to see, we will apply the current, stop the application of current and check how much is the time taken for the voltage to decline, right? That is what we are going to measure. So makes measurement of decay voltage produced due to polarization of the subsurface after the current flows, right? We apply current, stop the application of the current, but the subsurface of the earth remains energized. We are able to measure some potential for some time. This method is known as induced polarization method. It is used to detect metalliferous deposits, mineral deposits and also groundwater flow, right, especially along the earthen embankments. Groundwater flow triggers a natural electrical potential. Apart from that, when you induce large amount of current, the current is retained for additional time due to the groundwater flow. This can be detected by induced polarization method. Then the third electrical method is self-potential method. Here we don't apply any current, that is why it is called a spontaneous potential method based on the measurement of natural potential resulting due to different reasons. We are going to see little later, right? So we are going to measure the natural potential. This natural potential is subjected to the amount of groundwater that is present below the surface of the earth and also based on how the rocks are oriented below the surface of the earth. So this is known as self-potential method, often used in mineral exploration and also in groundwater studies, especially along earthen embankments, dams. On this side you have water stored in a reservoir, right? What is the location of the seepage phase can be detected by electrical self-potential method. So these are the 3 important electrical methods which we are going to see during this course. Then the next is electromagnetic methods. In electromagnetic method, we make use of response of the ground surface to the propagation of electromagnetic field. We generate electromagnetic field. So, here you can see a picture taken during a electromagnetic survey in the campus of IIT, right. A cable has been laid, right, in the form of a square, right. This cable carries current. The current carried over this loop generates some magnetic field. Response of the magnetic field by the Earth's subsurface is studied in this method. This method is known as electromagnetic method. So, what are all the broad applications of the methods which I introduced until now? Mainly used in exploration for groundwater, fossil fuels, mineral deposits, also in bulk mineral deposits, then more interestingly in engineering purpose, right, in geotechnical, water resources engineering, as well as in environmental engineering, mainly to understand the contaminant migration, right. Beneath the surface, contaminants may be migrating along a particular direction. This can be brought out by carrying out geophysical investigation at different times, right, also in archaeological investigations. Then the next is gravity method. In gravity method, right, when you go in a merry-go-round, you try to defy the gravity, right. So, you experience different levels of force when depending upon your seating in the merry-go-round. So, here is a location, right, where you have an option to sit at the outermost part of a merry-go-round or at a much more safer inner bench, right. You experience different level of thrill, right. Something that we measure in gravity method, right. In gravity method, we are going to measure the Earth's gravitational field, but what we are looking for, Earth's gravitational field will change due to the difference in the density of rocks. As I told you previously, beneath the surface you have a very thick, let us say half a kilometer of gold. The density is 19 gram per cc, right. So much dense material below the surface. So, gravity which you measure here will be much higher compared to a site where you have only soil. Here gravity which you experience will be lower. This is what we make use of to understand about the subsurface. Greatest advantage is this. I think I have put on the next slide too. It can be carried out on land, also on the sea, from air and on ice, right. So, let us take the same example, right. Gravity surveying helps us to understand about the types of rocks below the surface, helps us to understand about the cavities below the surface. Now, let us take the same example which we saw in the resistivity method, that is detecting magmatic chamber near the surface. Let us imagine this is the ground surface, right. This was one of the previous crater, that means volcano has erupted over there previously, that means there is a magmatic chamber below the surface, right. We want to know whether there is any activity that is going to occur in near future, whether the rocks in the chamber is beginning to melt, so that it may again rise and erupt. This can be also understood by gravity survey. How? Imagine we are doing gravity investigation in this area. We have noted down the gravity value. You are continuously measuring the gravity. When the rock begins to melt, what will happen? When the rock which was previously solid, when it begins to melt as a magma, right, that means The magma is a molten rock. When the temperature and pressure rises, the molten material erupts as a volcano, as you see in the picture, right? So, here is the ground surface. When the rock begins to melt, it may erupt as a volcano, right? When it melts, its density gets reduced, right? That is what. So, before it melts, the gravity value remains the same. When it begins to melt, gravity value decrease. When it becomes solid, again gravity value rise. So, when the temperature rises, the gravity value is very low. We have to be very, very cautious. Probably the magma may erupt as a volcano. So, here is one simple example of the application of gravity methods of surveying, right? Then what are all the applications of gravity methods? Here are the broad applications today. Gravity measurements helps us to understand about climate change, how climate change affects the water balance. We are able to make use of the principles of gravity methods. Exploration for fossil fuels, that is oil, metal deposits. In engineering investigations, to some extent gravity methods are also used in engineering investigation, in archaeological, military applications to understand especially large cavities below the surface. Are there any bunkers below the surface of the earth? Can be rapidly identified by gravity survey. The greatest advantage is it can be carried out on the sea, also from air, also from the land or sea. This is sea, land, also from an aircraft. This can be carried out, right? So, these are the greatest advantages of gravity methods. Next is magnetic methods. In magnetic methods, we are going to measure the anomalies of the subsurface by making measurement of the Earth's magnetic field. So, Earth's magnetic field will be affected by the magnetic properties of the underlying rocks. That means the Earth's magnetic field will be affected by the properties of the medium present below the site where you are carrying out the measurements. Suppose if the rocks below the surface of the earth where you are making the measurement of Earth's magnetic field has got lot of metals which are magnetized, which are capable of magnetized, right? For example, magnetite is one of the naturally occurring mineral which will function like a magnet. Suppose if you have a thick magnetite deposit at a region beneath the location where you are going to make the measurement of Earth's magnetic field, what will be the magnetic field you will measure? It will be much higher because beneath your location you have a thick deposit of magnetite, right? So, that is how magnetic method helps us to differentiate between magnetic materials from the non-magnetic materials, right? Now, let us take the same example, right? Now, we are trying to understand the change in the nature of rock present below the surface, right? How are we going to do? Just continuously we are measuring the changes in the magnetic field, right? Magnetic field intensity will decrease with the increase in temperature, similar to gravity methods. That means magnetic intensity will decrease with the rise in temperature. So, we can detect the rising magma, right? Let us take the same example. So, here is the ground surface. This was an ancient crater. Here is the magma melting. Rocks are melting, becoming magma. This can be detected by continuously making the measurement of magnetic field intensity at the surface, right? Here we are making the measurement of magnetic intensity. Before it melts, magnetic intensity is very high at time 1. At time 2, right, that means here the temperature is rising, This is temperature, this is the magnetic field intensity. When the temperature is less, magnetic field intensity was very high. At time 2, when you make the measurement, magnetic field intensity has got reduced. That means we have not moved. Our measurement station is the same. What we are doing? We are continuously measuring the magnetic field intensity at different times. But now the magnetic field intensity has reduced tremendously. What is the inference? Probably it is indicating the rocks here are melting. This is one of the classic application. I have taken the same example of rock melting to becoming magma to highlight you the application of electrical resistivity method. Previously we have seen gravity, now we are seeing magnetic methods. What are all the broad applications? In mineral exploration and also in military, to understand buried metal bunkers, right, and to understand large scale geological structures, we can understand the shape and size of ore bodies present below the surface of the earth. In oil exploration, also in engineering investigation, archaeological investigation, especially buried artifacts are made of metals, then magnetic methods can be deployed. Similar to gravity method, this can be carried out on the oceans as well as from air and obviously from land. From land, sea and air, we can carry out the investigations. This is of greatest advantage, right? So, gravity and magnetic methods can be carried out over a large area by deploying the tools in a aircraft. That is the greatest advantage of magnetic and gravity methods. Lastly, seismic methods. So, seismic methods are carried out by artificially producing the shock waves. So, here we are carrying out an investigation few months ago in the campus of IIT Madras, thanks to our collaborators from CSIR, National Geophysical Research Institute. They visited us with all the equipment. Here we are doing a seismic survey, right? What we are doing? We are energizing the surface of the earth, maybe with a large hammer blow. A hammer is used. We give a blow to the surface of the earth, right? That blow leads to some shocks. The shocks travel below the surface, get refracted or reflected back to the ground surface where they are received. A receiver. This is a source. Hammer is a source. Receiver. So, this is how we carry out the investigation. There is another way to do. Here we make use of ambient source. Then it is a passive method. In passive method, we don't produce any shock. Whatever shocks that exist naturally is measured, then it becomes ambient, whereas this is called as active. Right? So, here is a picture where we are continuously measuring the earth's tremor, right. Same thing is also done throughout the world. In India too, in all the meteorological stations, we have a seismic recording unit which continuously measures the earth's tremor, right. So, this is seismic method. So, in seismic method, we make use of two shock waves, right. Two different types of shock waves. One is primary, right, primary waves. Another one is known as secondary waves, P and S waves. Right. S waves do not travel in the liquids. S waves cannot travel through liquids, right. So, we can make use of seismic waves to understand about the melting of rocks below the surface of the earth. Let us take the same example here. In this zone, rocks are melting, becoming magma. Right. When rocks are becoming magma, imagine it is a kind of a small hillock. Imagine we are investigation, this is the source and here is the receiver. Right. On the other side, when the rocks are not melting, when it is a solid, when the rocks are solid, from the source, both primary and secondary waves will be received by the receiver. When the rocks in between is melting, imagine here the rocks are melting. When the rocks are melting, here we will not anymore receive secondary waves, isn't it? So, by making the measurements of primary and secondary waves, we will be in a position to say whether the rocks between the source and the receiver is it intact or melting. So, we have taken the same example to understand about seismic methods too, right? What are all the applications? Very often seismic methods are today used in geotechnical investigations to understand the soundness of foundation strata. Also, we have used a few years back to understand whether the ground improvement work which we have carried out has really improved the ground by making seismic measurements. How before improvement, after our ground improvement. Right? Often used to understand depth to the bedrock. This is the only tool helps us to understand greater depths below the surface of the earth, right? Several kilometers, whether the rocks are folded. This is the structure which we are looking for in oil exploration. Anticlines are usually trapping the oil, isn't it, right? There will be a cap rock which may be 5 kilometers below the surface. We are able to understand the structure 5 kilometers deep beneath the surface using seismic methods. Seismic methods can be also carried out from the sea. So, it can be carried out on land and sea, but it cannot be carried out from air. You cannot have a seismic tool from air. Why? Because you need a surface to conduct the shock wave. So, you cannot do it without making any intimate contact with the surface. So, it cannot be carried out from air like gravity and magnetic methods. So, we have had a look into some of the important geophysical exploration methods. Lastly, what are the limitations? Always we should also understand the limitations, right? Broadly, we have touched upon some introduction I gave you on these three methods. What are all the limitations? If you take electrical methods, when you conduct the survey on the surface, suppose if there is a buried pipeline, metal pipeline made of metal, the current which we apply will essentially pass through this metal, isn't it? So, it will give some furious results to us, right? Or on the other hand, beneath the place where you are applying current, there is a piece of rock. This will also affect our interpretation. Forget about that. There is there is a metal fence adjacent to our profile. Maybe at 50 meters, there is a metal fence. The current which you apply here will pass through the metal fence to the other location here, isn't it? It will short circuit. These are all some of the limitations. In gravity survey, adjacent to the location of your measurement, there may be a high-rise building. Yeah, a big building may be present, right, adjacent to the site of your investigation. So, in such a case, this is the location where you are making the measurement of gravity. There may be a huge building. This building will also attract your mass in the instrument. Gravimeter is an instrument. The mass will be attracted by a building, or there may be a huge mountain. This mountain also will attract this. We need to overcome this by carrying out some corrections. In this case, however, we can remove this effect by carrying out some corrections. Magnetic methods. Presence of a metal object, a metal tower, electrical cables, electrical wires running overhead, posts made of metals, they will cause some noise to the measurements we are making. Lastly, seismic methods. Seismic method, we are giving, as I told you, we are giving a hammer blow on the surface, right? Apart from hammer blow, there may be a tree, a big tree. This tree will also be oscillating, isn't it? This tree will be, due to the wind, it will be moving, swinging either side. This will also create some shocks. This shock also will be transmitted and you will have a receiver. This shock also will be received. For example, last time when we did a seismic survey, very in the close vicinity, there was a generator running. That generator's noise shocks were also picked up by our instrument, right? So this is how the geophysical methods are also having some limitations, and also we will measure some noises. We have to be aware of that. We need to keep them in mind when we carry on with our interpretation. So thus in this lecture I have introduced you very broadly what are the applications of different geophysical methods. Initially we had a look into what property we are measuring, which property of the earth that control the measured parameter. Then we had a look into four major methods of investigations. Electrical had three methods. Then we had seen gravity, magnetic and seismic method. In all the four methods I have nicely explained how we can understand whether the rocks below the surface is melting. What will be the response of melting of rocks in all the four signals. Then I had also shown you a table in which how these four methods are applied to different questions which we may have. For example, slope stability, geology, hydrology, which method can be made use of. Hope you would have had a thorough understanding of broad applications of different geophysical methods. Thank you very much.